Hi, welcome to Complex Numbers, Part 2. In this video, we're going to talk about rationalizing the denominator and conversion between rectangular, polar, and exponential coordinates. So let's get started. Rationalization is a review of something you've already seen. So for example, if we have the equation 5 plus 2j divided by 4 plus 3j, we would just take the opposite of the bottom part. So for instance, in this case, we would end up multiplying it by 4 minus 3j over 4 minus 3j. And now we just have to properly multiply and distribute using the first outside, inside, last. So 5 times 4 is 20, 5 times 3 is 15, 2 times 4 is 8, and 2 times 3 is 6. And we'll do the same thing on the bottom. And we'll collect our like terms, so there's nothing that we can put with the 20 yet. The 15 and the 8 go together, so it's minus 7, and minus 6j squared. And we'll do the same thing on the bottom. But you'll notice that the minus 12 cancels out with the plus 12, so you have no j's in the bottom. It's minus 9j squared. Now remember, j squared is actually equal to negative 1. So we can substitute that in. So after I do my substitutions, 20 plus 6 is 26. Minus 7j over 25. That's rationalizing the denominator. As a result, there is no imaginary parts on the bottom. If we look at another example, 3 minus j over 5 minus 2j, we're going to multiply it by the opposite of the bottom part. So 5 plus 2j over 5 plus 2j. And we FOIL it or distribute properly. That gives us 15, 6, 5, 2. On the bottom, it's 5 times 5 is 25. 2 times 5 is 10. We'll do 2 times 5 again, and then we'll do 2 times 2. We also need to remember that j squared is equal to negative 1. So we are still going to substitute that in. And we'll notice that the j's cancel each other out. And so we have a final answer of 17 minus j, all that over 29. Now there are times you're going to have to convert from rectangular coordinates to polar coordinates, and also from rectangular coordinates to exponential coordinates, and from exponential to polar coordinates. Being able to do those conversions is particularly important when you're giving instructions or descriptions to different groups of people. I'm going to convert 3 minus 4j from rectangular into polar and then into exponential components. We need to remember that the general equation for rectangular coordinates is x plus yj. Therefore, the x is equal to 3 and the y is equal to negative 4. The general equation for a polar coordinate is r to some angle, theta. It's usually in degrees. So obviously we need to find our r, and r is just the hypotenuse. R is equal to the square root of x squared plus y squared. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, so the root of 25 is 5, so r is equal to 5. And if we think back to trig, theta is just equal to the arctan of y over x. And y is negative 4 and x is 3, so the arctan of that ends up being 53.1. So we need to be careful. It's negative 53.1. So it's actually meaning that we're going to go around 360 degrees. And we're going to go back 53. So in this case, our theta is actually equal to 306.9 degrees. Now we're just going to plug it into our polar equation, which is r is equal to 5, and our angle is 306.9. You could see polar coordinates written as r cos theta plus r sine theta. Don't forget the j, we need it, because it is the imaginary part of the number. Writing it like this makes life a lot easier in a little bit. Now we're going to go from rectangular to exponential coordinates. We'll use the same equation, 3 minus 4j r exponential j theta. Well, we already have r, which is equal to 5. It's the hypotenuse of 3 and 4. Now this theta is in radians, so we have to convert our calculator into radians. But the way we calculate it still remains the same. Theta is equal to arctan y over x. Now remember, your calculator has been converted into radians, so this is negative 0.9273 radians. So going all the way around is 2 pi, but we just go 2 pi and then we subtract 0.92. So our theta is 5.356 radians. Now we just fill out our general equation. Our r is equal to 5, and our theta is equal to 5.356. And now we're going to go from exponential to polar form. And we'll look at the example of 7 times e to the power of pi j. We know that the general form of an exponential is r e theta j. So therefore, r must equal 7, because that's the first part, and the theta has to equal pi, since it is this part here. The other thing to remember is that the equation tends to be in radians, so your angle is also in radians. So the exponential form tends to be in radians, but we have to change that to be degrees because polar is in degrees. So the degrees is equal to the angle in radians times 180 over pi. This 180 over pi, it never changes. Now the angle in radians, in this case, it's pi. It's just the angle that's given to us, or it's the theta. As it happens in this case, the pi's cancel each other out, and so our answer is equal to 180. So therefore, our theta is equal to 180 degrees. So our general form for polar is r angle theta. So our r, we already figured our r to be 7. And our theta, in this case, is 180. Let's look at another example of converting from exponential to polar form. So if we have 2e to the power of 3.421j, what would that be in polar coordinates? So the general form, as I stated before, polar coordinates is r theta. Well, if we look at this, r is equal to theta j. We know that our r is equal to 2, and we just have to figure out our theta in degrees. Because right now it's in radians, we can easily make that change. So we know that degrees is equal to 8 angle radians times 180 over pi. So 3.421 times 180 divided by pi, which is going to give us 196. So we know our r is equal to 2. We know our theta is equal to 196. So then we're just going to plug it into this equation. So 196. Now, as promised a couple minutes ago, we're going to go from polar to rectangular. And remember, I said that our angle could also be written as r cos theta, r sine theta j. But if we look at this, this is very similar to the rectangular equation of x plus yj. So therefore, x would equal to r cos theta, and y would equal to r sine theta. In our example, r theta is equal to 296 degrees. We can just plug it into our equation. R is equal to 2, and theta is equal to 196. That ends up being negative 1.92, and now we're going to figure out the y. Just plug it in chug, and that ends up being negative 0.55. And if we just do a quick sketch, it kind of makes sense, right? 196 degrees would be down over here, and this is the line. It goes a whole bunch across the x, and it goes down very little y. I hope that helped. Please be sure to leave a like so I can brag to my boss how many likes I get and the people I work with how popular I am, and I can tell my daughter I'm a YouTube creator.